Welcome back. Still practicing Hess's law here. So we're given two reactions and we're allowed to reconfigure these and use some combination of them to make this reaction. And generally you just start with your first species and work your way across. They start by saying we need a reaction that has NO, 1 mole of it on the left side. Reaction 2 here doesn't have any NO in it, so it can't help here. Reaction 1 does have NO, but it's on the right side. So if we flip reaction 1, the two sides switch, we get NO on the left. On the right, we'll get both of these things, half a nitrogen and half an oxygen. Okay, so that takes care of our NO part. The next thing we need is half an oxygen, and generally I tell people if there's a species that you could get from two different reactions, put it off until later. They tend to be the hardest, and hopefully it'll take care of itself, or we'll end up with no choice about how to do it. So hop over that one for now. Next species we need is NO2 on the right, and reaction 2 uniquely already has NO2 on the right, so we can take reaction 2 as is, no changes required. I can just copy that one. 1/2 N2 plus O2 produces NO2. So that's all the reactions, so we're kind of hoping that that was enough to do what we needed. If we simplify this, we can cancel half an N2 on each side. That gets rid of the nitrogen completely. Both sides have oxygen. We could remove half an oxygen from each side. That gets rid of this completely. And instead of one oxygen, we're left with half an oxygen. And so our total is we have NO. Oh, I'm sorry. This is also left side. We have NO plus half an O2. That's all our left side stuff. And on the right, we have NO2, which is exactly the reaction that they wanted. So the point of doing all this is we want to find the delta H for this reaction. And if we flipped reaction 1, that means we flipped this delta H, so it becomes negative 90.5. If we kept reaction 2 unchanged, that means we keep this delta H unchanged. It's still 33.9 positive. And when we add two reactions, we add their delta H's. And if you add those together, you should find you get negative 56.6 for the delta H. And the unit for that, as usual, will be kilojoules.